questions 21 through 25 on the 2018 grade 12 AMC 12B. In triangle ABC with side lengths AB is 13, AC is 12, and BC is 5, let O and I denote the circumcenter and incenter respectively. A circle with center M is tangent to the legs AC and BC and to the circumcircle of ABC. What is the area of triangle MOI? Well, here is that diagram, and don't get too overwhelmed by it. I'll go through it step by step. So first, let's talk about the incenter. And the incenter is basically going to be the midpoint of that circle that is inscribed inside the triangle. So the triangle is ABC, and inside we have a circle that's inscribed, and the incenter is the center of that. Another way you could talk about it is where the angle bisectors meet. But in this case, I think it's easier to understand it as the center of that circle that's inscribed in the triangle. And they have denoted it I. And since we have a formula that can figure out the radius, let's use that formula. That formula is A is equal to P times radius over 2, where P is the perimeter. Well, the area would be 1/2 base times height, since we're talking about the area of that triangle, ABC. And since the dimensions are 5, 12, and 13, that is right, because 5 squared plus 12 squared is 13 squared. So 1/2 base times height, so it would be 1/2 12 times 5. And the perimeter, well, that's just 5 plus 12 plus 13, which is 30. Yeah. And then R, which is what we're trying to figure out, over 2. So this looks like it will be 60 divided by 30 is equal to R, and therefore R is equal to 2. So that means the radius is 2. So from there to there is 2, from there to there is 2. So we can easily, if we were to, for example, put this on a coordinate plane, easily figure out the dimensions of that. And let's just put it on a coordinate plane, and then let's talk about it. So I put it on an XY plane, and now the coordinates obviously would be 2, 2, since the radius is 2. 2 over on the x-axis, 2 up on the y-axis. So very quickly we got 2, 2 as the coordinates of I in center. Now let's talk about the circumcenter. The circumcenter, I will just draw it in. That's a little bit easier to figure out. It's basically where the perpendicular bisector of the sides meet. So basically we're going to chop this 12 in half. So like that. And we're going to chop this 5 in half. So like that. And as you can see, O is what they've designated as the circumcenter. So that is O. I'll just get rid of those lines to avoid confusion. I just want to put them in to let you figure out how you got it. Now, the coordinates of O are also going to be easy to figure out because it's halfway. So remember, it was halfway of 12, so that's going to be 6 on the x-axis. And on the y-axis, it's halfway of the 5, which is 2.5, or 5 over 2. So there we go. We've got 2 of the points. We've got O and we've got I. If we can figure out the actual coordinates of M, then we can figure out the area of that triangle. Now let's read the next part. A circle with center M is tangent to the legs AC and BC. Okay, so I'm assuming this circle right here, it has the center M and is tangent, as you can see, to AC and BC. And to the circumcircle of ABC. So there's a circle that goes all the way around the triangle ABC. And that circle is tangent to that as well. So I'm assuming that's going to be point P, the point of tangency. And with those facts, you can conclude that M, P, and O are collinear, meaning they fall on the same line. And that's because MP and OP are perpendicular to the common tangent line at P. So with that piece of information, we can conclude that MO, that distance, is equivalent or equal to OP minus MP. And MO therefore is OP. OP is just the radius of the big circle, and we can easily figure that out with Pythagoras, where this is 6 and this is 2.5, like that. And when you do, I'll just do it on the side here, that big R would be 6 squared plus 2.5 squared, R squared that is, and when you do that math you get R equal to 6.5, and that's OP, 6.5. And then MP, well, MP, since MP represents the radius, and this is also the tangent point, and it's also tangent here, if this is R, this is R, and this is R. So on the coordinate plane, if this was, say, whatever letter you want to use, say P, then the distance from here to here would be P. So the coordinates of M are of the form PP. So we could just put that in here, P and P, like that. The X and Y coordinates are the same. So the distance from M to P is just the radius, and the radius of that circle is just equivalent to P. So I'll put that in there. Okay, we can figure out MO in another way using the distance formula, using this point and this point, O, where O has the coordinates 6 and 5 over 2. So using the distance formula, we get 6 minus P squared plus 2, or we'll use 5 over 2, it doesn't matter, 2.5, 5 over 2, minus P squared, all under the square root sign. And when you expand that out, I'll let you guys do that. You get the following. Expand it all out, and then you collect like terms. What you're doing essentially is equating this MO with this MO. So that would mean 6.5 minus P is equal to this big long 6 minus P squared plus 2.5 minus P squared. And when you, I'll just do it for you, what the heck. If you expand this, you would square both sides, and then you'd get that. Let's expand that. 36 minus 12P plus P squared plus 2.5 squared minus 5 plus P squared. And this side, 6.5 minus P squared, is 6.5 squared minus 13P plus P squared. And this we can easily collect like terms and put it all on one side, and you get P squared minus 4P. Factor out the P, and that gives you P minus 4, and therefore P is equal to 4. So the radius of that circle is 4, therefore PP is 4, 4. So M is 4, 4. So I have O, and I have M, 4, 4. So I have all 3 points of that triangle, MOI. Now I can calculate the area. So I have I, which is 2, 2. I have O, which is 6.6 and 2.5. And I have M now, which is 4, 4. So now I have to show you how to figure out the area, and you do that with something called the shoelace theorem. And I will show you, let's say we have 3 points, A1, B1, A2, B2, and A3, B3. And I said, figure out the area. The shoelace theorem says that the area is 1/2 times the absolute value of A1 times B2 plus A2 times B3 plus A3 times B1. Subtract from that B1 A2 plus B2 A3 plus B3 A1. Absolute value. So using that theorem on those coordinates, I guess, it would be 1/2 absolute value, so it would be 2 times 2.5 plus 6 times 4 plus 4 times 2. And then subtract from that 2 times 6 plus 2.5 times 4 plus 4 times 2. Okay, so this is 5 plus 24 plus 8 minus 12 plus 10 plus 8, and that is 37 minus 30, and that is 7/2. And that's it. Challenging question. Number 21. The answer is E. Consider polynomials p at x of degree at most 3, each of whose coefficients is an element of 0 to 9. How many such polynomials satisfy p at -1 is equal to -9? Well, I will let p at x equal ax cubed plus bx squared plus cx plus d. It's a polynomial of degree at most 3. So the highest this can be is 3. It could be 2 if a was 0. It could be degree 1 if a and b were 0, and so on. We have a condition that p at -1 is equal to -9. So when you put x equals -1, you get -9 is equal to minus a plus b minus c plus d. And therefore, if we rearrange this a little bit, multiply through by -1, we get a minus b. And then, a minus c rather. A plus c, sorry. And then minus b plus d. So we have to do a little bit of thinking here. That basically means that if I put one group on the other side, it would be a plus c is equal to b plus d plus 9. So I will let b plus d equal to k. And that means that a plus c is equal to k plus 9. And my k ranges anywhere from 0, 1, all the way till 9. So now let's figure out what are the possible values. So there are k plus 1 solutions to b plus d equals k. For example, if k was 9 and we wanted to create a b plus d equal to 9, how could you do that using these numbers? Well, you can have 0 and 9. You can have 1 and 8, 2 and 7, 3 and 6, 4 and 5, 5 and 4, 6 and 3, 7 and 2, 8 and 1, and 9 and 0. And as you can see, that is 10 which is k plus 1. So it takes a little bit of thought there. And then in a very similar way, you can figure out that there are 10 minus k solutions to a plus c equals k plus 9, the next one. So for example, if k was 9, that would mean a plus c is equal to 18, and the only way to do that is 9 and 9, and as you can see, that's only 1. And since k was 9, 10 minus k is 1, so it matches out. And you can verify that for other values if you're interested. All right, so now we get to the end of the question, that the total number of cases, we want this and this. So the number of cases here have to be multiplied by the number of cases here to give the total number of cases. So the total would be the number of cases of b plus d equal to k, which was k plus 1, multiplied by the total number of cases where a plus c is equal to 9 plus k, and that was 10 minus k. And all of these have to be added up, and remember k was going from 0 to 9. 0 to 9. So this is our formula right here. So we can figure this out now. Let's do this. When k is 0, we've got 1 times 10. Then we got 2 times 9 when k is 1. When k is 2, we would have 3 times 8, and so on. We got 4 times 7, 5 times 6, 6 times 5, 7 times 4, 8 times 3, 9 times 2, and 10 times 1. And when you add these guys all up, it's 220. So number 22, the answer is 220, which is choice D. AJ is standing at a point A near Pontianak, Indonesia, 0 latitude and 110 degrees east longitude. Billy is standing at point B near Big Baldy Mountain, Idaho, USA, 45 degrees north latitude and 115 west longitude. Assume that Earth is a perfect sphere with center C. What is the degree measure of ACB? All right, we need a diagram for sure. So I'll draw a quick diagram that sort of illustrates kind of longitude and latitude. Let's say this is the cross-section of a sphere. And very quickly, if this is, say, the diameter, if we are at a point 110 degrees east, then from here, this is the starting point, it would be approximately here, 110 east, because we're counting from there. And then the other one is 115 west, so it's approximately here, 115 west. And again, we're counting from here. So now we can easily figure out this angle. It'd be 360 minus 110 minus 115, which is 135. So this angle in here is 135. So in this diagram, basically to go from A to B, the point where AJ is and Billy is, you'd go first from here to here, which is 135. So I guess I'll just put that in there, the degree measure from there to there. And then at that point, you will still be on the flat sort of, if you were to get that hemisphere, you'd be right there. But you have to go up 45 degrees in order to get up to where B is. So first you'd have to travel 135 degrees, and then you'd have to go up 45 degrees. Now, the way this is drawn is to help you where this is a right angle, and then therefore this is 45 degrees, like that. So now, since this is on an XYZ plane, let's give A and B some coordinates if we can. I'll just say this sphere has a radius of 1. So that means A would have the coordinates 1, and then it doesn't go anywhere on the y-axis, and it doesn't go anywhere on the z-axis. So it's 1, 0, 0. So that's an easy one. But now I've got to figure out coordinates for B, for x, y, and z. Well, from here to here was 135, so that means from here to here is 45. And therefore, if we were to draw a line from that base point where B touches down to here so that it's hitting at a right angle, it's on a slant there, that's why it doesn't look like a right angle, but it is, then that means we've got a 90, 45, 45 triangle again. And therefore, this x coordinate, which would be from there to there, in terms of its magnitude, would be the same as that, since that's an isosceles triangle, right? That's equal to that. 45 degrees, 45 makes it isosceles. So it's going to be on this side, so let's just say it's A. So the x-coordinate would actually be minus A, sits on the other side. The y-coordinate, well, that's going to be positive A, since we're in the positive direction. And then the z-coordinate, that I don't know, so I'm just going to put z for now. How I get the z-coordinate, I would actually have to use Pythagoras. Now to figure out z, which is essentially the top to bottom distance there, we can figure out this first, and since that is a 45, 90, 45 triangle, this one, this side is the same as this side. So if we can figure out one side, we'll be able to figure out the other. So let's concentrate on figuring out that side, and we can do that easily with Pythagoras. A squared plus a squared is equal to z squared. Since this is z, but this is also going to be the same as z, since those two sides are the same, since that is an isosceles triangle, since two angles are 45 degrees. So that means 2a squared is equal to z squared, and therefore z is equal to root 2a. Okay, so we can get rid of this z and put in root 2a. Okay, so I got the coordinates for B. It's in terms of A, but it will help us. Now, I had previously set the radius of this sphere to be 1, and that's why I put that 1 there. So that means that radius is also 1, since it's going from the center to the edge of the sphere. So that means the magnitude of this point minus a root 2a will be equal to 1. So how do you figure out the magnitude? Well, it will be minus a squared plus root 2a squared, square root, and that is equal to 1. So this is a squared, 2a squared, so 4a squared, root is equal to 1, so that means 4a squared is 1. That means a squared is a quarter, a is a half. So that means this point, the coordinates are minus a half, and root 2 over 2. So now I can figure out the distance from B to A, that right there. The distance from B to A, I can use the distance formula, and I can do that. That would be, I'll do it over here, B to A. So negative a half minus 1 all squared, plus a half minus 0 all squared, plus root 2 over 2 minus 0 all squared. So this is going to be minus 3 over 2, so 9 over 4, plus a quarter, plus 2 over 4. And that's going to be 12 over 4, the square root of, and that is just root 3. Okay, so BA is root 3. Now the final step to figure out that angle is ACB, where the center was called C, we can use the cosine law on that triangle ACB. And that's going to be AB squared is equal to BC squared, which is just the radius, which is 1 squared, plus AC squared, which is just the radius, 1 squared, minus 2BC, 1, AC, 1, cos of that angle, ACB. So AB squared, or BA, AB, BA, same thing, that's going to be just 3, and this is going to be 1 plus 1 minus 2 cos ACB. So 2 cos ACB is 2 minus 3, which is negative 1, and therefore the cos of ACB is negative 1/2, and therefore ACB is 120 degrees. So number 23, the answer is C. Let x bracket denote the greatest integer less than or equal to x. How many real numbers x satisfy the equation x squared plus 10,000 times x bracket is equal to 10,000x? So we have x squared plus 10,000 bracket x is equal to 10,000x. Let's bring the x squared to the other side. So this side would become root x is equal to 10,000 x minus x squared. And therefore now I can divide through by 10,000. And it's going to leave me with just x minus x squared over 10,000. All right. Now, what is x? I am not sure, but x is an integer part plus a fractional part, correct? So therefore, if I take the bracket x, it becomes just the integer part. That's basically the definition. So for example, 4.3, if that's x, if I take the bracket of that, it just gives me 4. So substituting that in here, this becomes I. This is I plus f, and this is just, I'll just leave it as x squared over 10,000 for now. Now the i's cancel on both sides, and therefore if I bring the x squared over, I get the fractional part is equal to x squared over 10,000. Now the fractional part, obviously, it's between 0 and 1. So that means that this x squared over 10,000 is obviously less than 1, but greater than or equal to 0. Multiply through by 10,000, and we get x squared is less than 10,000, or greater than or equal to 0. And therefore, x is going to be between 100 and negative 100. And therefore, x could be minus 99, minus 98, dot, 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 all the way to 0, and then dot, 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 all the way up until 98 to 99. Now that gives me, if you count up those integers, 199. And for each value of x bracket will correspond to one value of x. Now this question is a little confusing because x is a real number, right? Real number x. X, they don't specify as an integer. X bracket is an integer. But apparently, for every value of x, you get one corresponding value of x bracket. So as we can see, the solution seems to be invalid at first, but one cannot determine, because one cannot determine whether x is an integer or not, right? Because x, they're just saying, is a real number. However, it actually works because although x itself might not be an integer, it is very close to one. So there are therefore 199 potential x. So I kind of racked my brain on this because I said, okay, this is great if x was specified to be an integer, but x is being told as a real number. But apparently, if you read this, we can assume that because x is very close to an integer, we just look at the integer values. And therefore, when you count up all of them, you get 199 such values. So therefore, number 25, the answer is C. Circles W1, W2, and W3 each have radius 4 and are placed in the plane so that each circle is externally tangent to the other two. Points P1, P2, and P3 lie on W1, W2, and W3 respectively, so that P1, P2 equals P2, P3 equals P3, P1. And the line PI, PI plus 1 is tangent to WI for each I equal to 1, 2, and 3, where P4 is equal to P1. See figure below. The area of triangle P1, P2, P3 can be written in the form root A plus root B, where A and B are positive integers. What is A plus B? So the first thing I'm going to do is draw some helpful lines. The first line is going to be from the center to P. So like this. And I can label that center. Let's just label it approximately here. And I'm going to call that O1. And the second one, very similarly, if this is, say, O2, that center, I will draw a line from P2 through that. So it will be approximately like this. And then the intersection point of those two green lines, I will call K. So K is right there. Okay, so now they had told me that this line right here is tangent to the circle. So that means that this angle is 90 degrees. And if that angle is 90 degrees, then this angle is 90 degrees. And this triangle is equilateral. That's pretty much what that means. All the sides are the same. So that means this angle is 60 degrees. And in a very similar way, this is also the tangent. And therefore, this is 90 degrees. And if that's the case, if this is 90 degrees, then this will be 30. 90 minus that 60. So put 30 in there. And therefore, this angle must be 60. So we've got ourselves a 30, 60, 90 triangle. And as always, the ratio of the sides are 2, 1, and root 3. So I will call this D. This will be 2D. And this, from here to here, is root 3D. Those distances. So now we will draw one final line from O1 connecting it to O2. And at this point we can proceed with law of cosines. And law of cosines in particular on the triangle that has been created from the points O1, K, and O2. So that triangle, we will use law of cosines. So O1 to O2, I'll just write out the lengths instead of making the diagram messy. That is the distance from the center of one circle to another. So the distance is basically 2 radii. And since the radii is 4, that distance is 8. The next side of that triangle O1 to K, well, from here to here is the radius, which is 4, and from here to here is D, so it's 4 plus D. And then the other side, which is right here, that is O2K, this whole distance from there to there is 2D, and this distance is 4, so it would be 2D minus 4. So now let's proceed with the law of cosines. 8 squared is equal to 4 plus d squared plus 2d minus 4 squared minus 2 times d plus 4 times 2d minus 4 cos of, what's the angle? The angle is 60. So now let's do this. We have a little bit of room here. 64 is equal to d squared plus 8d plus 16 plus 4d squared minus 16d plus 16. Now the cos of 60 is a half, so that will just cancel with that 2. So I can just expand those two guys now. 2d squared minus 4d plus 8d minus 16. Okay, so now we just have to collect like terms and all that stuff. So 64 is equal to d squared, 5d squared actually. This guy and this guy. And then minus 8d plus 32 minus 2d squared. And then that's 8 minus 4, 4. So minus 4d and then plus 16. And then putting it all together, it's going to be 3d squared. And then let's see here, minus 12d. And it will be minus 16. And that equals 0. Okay, great. So now all I have to do is just figure out d using Pythagoras. Using the quadratic formula. So 12 plus or minus the square root of minus 12 squared minus 4ac all over 2 times 3. So this is 12 plus or minus 144 minus 144 plus 192 all over 6. And that looks like 2 plus or minus 144 plus 192 is 336. And 336, I believe that is 4 root 21 all over 6. So there we go. Or you can simplify this a little bit further. First and foremost, we need the positive value because d represents, of course, a distance. And then this can just be root 21 over 3. 2 root 21 over 3. So d is that. So we can now figure out the side length of that equilateral triangle, which is root 3 times d. So root 3 times d would be 2 root 3 plus 2 times root 63 over 3, which is 2 root 3 plus, what's that, 9 times 7, so it would be 2 times 3, so 6 divided by 3 is 2, so 2 root 7. Okay, and that is the side length of the equilateral triangle. Now, I hope you remember the area of an equilateral triangle. There's a formula for that. It is very beneficial to know that because it saves a lot of time. And that is that the area would be root 3 over 4 times a squared, where a is the side length. And this is our a. So use that formula. A would be root 3 over 4 times 2 root 3 plus 2 root 7 all squared. And let's expand this now. So root 3 over 4, it would be 2 root 3 times 2 root 3, so it would be 3 times 4, which is 12. And then you would have 2 times 2, 4, and then 8 root 21 plus 2 times 2, 4 times 7, 28. So this is root 3 over 4 plus 40 plus 8 root 21. So this is going to be 10 root 3. And then this will be 8 root 63. So it'll be 10 root 3. And 63, as before, was 3 times 7, so it'd be 3 times 8, which is 24 over 4, which is 6, so 6 root 7. Okay, but they're saying that it's got to be in this form, just root A and just root B. So we have a mixed root where they don't want that, so that's okay. I can just put it inside. So it'd be 3 times 100, so root 300, and this one would be 36 times 7, which is 252. And this is the form that they want, root A plus root B. And then they want you to figure out A plus B. Well, A is 300, B is 252, and therefore 300 plus 252 is 552. 552 is the answer, and therefore number 25, that would mean D.